You have f of x we'll do 6, so we'll say plus 5x. So we have that one, and then I'm trying to think of all that factors quickly. So we'll do -12. Yeah, we'll do that. So let's say we have a piecewise function that has quadratic. How do you graph that? Well, you graph it the exact same way you would if it wasn't piecewise. And just erase the domain. Remember how we were doing it that way? It's a little bit longer to go that route, but it doesn't hurt any. So let's say this one is for all x values that are less than or equal to 3, and this is for all x values that are greater than 3. Real simple, nothing too crazy. We're just making up a piecewise function with a quadratic. I just wanted to show you guys how you can graph that, just like we did with that linear stuff on that worksheet from last Tuesday when I was it Tuesday? No. Thursday, when we did that stuff on Thursday, okay? So let's walk through it. We had the two functions, x squared plus 5x plus 6, where x is greater than or equal to, less than or equal to or greater than or equal on that one?
Less than or equal.
Thank you. And then the other one was x squared minus x for everything greater than 3. Okay. When you graphed quadratic, what we did is there's a couple of ways of going about it. You can do your axis of symmetry, get your vertex, plot it, and go. Or you can go and rewrite it, find your zeros, and do that route if you want as well. To be honest with you, I think it's always easier to go with your axis of symmetry. Remember and then get your vertex out of that. Remember that? How do you find the axis of symmetry?
Something 0 on the bottom.
No, that would be a big negative.
Oh, I was thinking
Yeah.
of something.
How do you find the axis of symmetry on a quadratic? Yeah.
Negative b, opposite of b over a.
Close. 2x. So remember, your axis of symmetry for a quadratic is the opposite of b over 2a. And the reason why we find that first is because we know that the graph will be symmetrical about that. It folds in on itself. We also know that that value of x will be the x coordinate for your vertex. So you know where it's going to start. Really, really fast. So what's the opposite of 5 over 2 times 1? Negative 5.
Yeah.
Negative 5.
Excellent, ladies. Negative 5 halves is what?
That x is,
Correct. So it's what? Negative 2.5-ish?
yeah.
Okay. So I would start my graph negative 2.5-ish. And remember, that axis of symmetry was that dotted line. Because it doesn't really exist. It's just there to help us visualize. Okay. If the axis of symmetry is at x equals negative 2.5, what's that? Yeah, we're doing it piecewise. So I'm going to show you how you do it with the quadratic. It's the same way as you would linear. It just has a curve. I know that'll be at negative 2.5. Now I just use my calculator. When I use my calculator, I only got this thing installed.
No way.
What?
To install.
Oh. Of course, it says my license isn't right, but the license was right there on the CD that I used. So. Okay. Let's see how this works. Where's the key buttons? It's just started working today.
Welcome to
Where's the touch pad? Oh, here it is. Found it.
Good job.
So, with any luck, I think my screen just looks a little bit different than what yours does, because this is not the cast, so it's pretty similar. So, we put in parentheses, where's my negative 2.5, close the parentheses, and I'm going to square it. To that I had to add, what did I have there in the middle? 5x. So 5 parentheses, negative 2.5, and then I had to add 6. So it's quite literally substitution, okay? Hit enter, and there's your vertex. Your vertex will be located at negative quarter, okay? So for this example, it just so happened that I was just picking numbers randomly out of a hat to figure out where I was going to put this. It kind of wound up with the worst case scenario, if you will, as far as placing something on a graph. Just by saying that, I know my graph will have a vertex here. Okay. I know it. If I go further into that, I also know that it has zeros. Because what times what's 5 you add together to get, or what times what is 6 you add together to get 5? 3 and 2. So if my terms are going to be x plus 3x plus 2, what are the zeros? Negative 3 and negative 2. So I know that I'll have points here at negative 2 and negative 3. Okay? Just getting those zeros. Yep, that's all it is. Yeah. Because remember, the axis of symmetry always, your vertex always hits that, so it's got to be on that. It has to be, otherwise it won't work.
Wait, what did you get the negative 3?
What are the zeros? I just factored it, because I wanted to give you guys something that had a quick value for factoring, so I figured what times what's 6, you had to get 5, 3 and 2. Those are your terms, your zeros would be negative 3, negative 2. If I used 0, for example, if I use 0 for this, for x, what's my y value? 6. On the other side of it, to mirror it, this was 2.5 away. Well, here's 2.5 away here. You okay with that? I'm using symmetry just to find them. I'm picking really, really, really silly numbers, really easy numbers to work with. It just makes your life easier. It's close to 0, might as well use it. I know that my curve is going to look something like this. Okay? I probably should have done that with a smaller domain. We'll come back to it. Do the same thing on the other one. When I go to the other one, I'm going to show you how you can plot it a little bit differently. Okay? A little bit differently this time. So if I plot this a little bit differently, I'm going to go right to the zeros for the second equation. What times what is negative 12 you add together to get negative 1? Negative 4 and positive 3. So I know that this would be x minus 4, x plus 3. Where will my zeros be for that? 4 and negative 3. Really didn't want to wind up with the same 0. Whatever. What happens halfway between those two values? Okay, so what's 4 plus negative 3? 1. What's half of that? 1/2. So my axis of symmetry is going to be at 1/2. What lies on the axis of symmetry? Vertex. So all I have to do is substitute in 1/2 into this then. They do the same thing. Use your calculator, just use 0.5, it's quicker. Okay? Use 0.5 and you'll find your vertex. What was it? 0.5 squared minus 0.5, and then it minus 12. Thank you. Negative 12 and a quarter. So my vertex will lie at negative 12 and a quarter. I'm going to plot it. It's close enough. Okay. Which way does this open? Up like that. So this is opening up like I thought. We already have points here we can just go ahead and use. If I wanted to plot it at 0, I know that I'd have x was 0, y would be negative 12. So it's just that little bit off.
So do you want us to actually like write the points?
Well, what happens a lot of times when you're graphing it, the vertex is really the point you're going to use usually is going to be the vertex and possibly the 0th depending upon what the domain does. Okay. Here, I was hoping that it wasn't going to overlap like that. Let's see. Let's say our domain then. Let's say, for example, it all fit on a graph and you wanted to see which ones they were. Okay. Instead of being at 3, I didn't realize I had shifted it this far. What I'm going to do is just have it be at less than or equal to negative 1, just so I can show you how you would erase stuff. Is that okay to change that out? I'm going to change that to negative 1, and I'll change this to negative 1. Oh, I didn't see someone there. Sorry.
Yeah, he knocked.
No, I thought somebody knocked that was walking by because he was on the door. He wasn't in the window. I didn't see him. Thank you. All right. So all I did here is, like I said, I was just making up problems out of thin air, trying to figure out, just to show you guys how the domain stuff would work. I'm changing my restriction to be at negative 1. Just, okay? So I look at negative 1. This graph is going to be only shown when the x is at negative 1. Well, obviously we're not perfect here about what our exact value might be. So we've already plotted our zeros. We plotted our upper points. I'm going to, oh, I didn't even move it. I'm going to go ahead and just erase my domain above negative 1, and I'm just going to put a solid dot there. It's going to be a solid dot on that one. It's going to be a solid dot on that one because it's got a less than or equal to. So it's going that way. Does that make sense? We're erasing the domain that it doesn't exist at. So then on the other one, I'm going to erase it rising up. But what do I put there at that one value? Open dot. That's it. And then I just erase the rest of this. Oops. I put in an open dot because it's just a greater than symbol as opposed to greater than or equal to. Okay? That's the only thing that's different for graphing a quadratic with a piecewise. It just takes a little bit longer. I mean, I know you guys all know how to graph quadratics. You've done it a lot. You did it a lot last year, whether you were in standard form, vertex form, intercept form. There's all the different ways. So it's totally up to you guys how you want to go about plotting them through. I'm only asking that you give me the vertex and throw a couple of points on there that make sense. More often than not, you're going to be looking at your zeros or where it crosses the y-axis just by substituting for 0. Okay? Does that make sense? Okay. The other stuff then, as far as what's going to be on the test part tomorrow then, when we're looking at the graphing, can you pick numbers that make sense if you have to plot something that has a shift? Remember when we were talking about the square root functions last week when we did the picking up the numbers? You have a question or you remember that? All right. For example, if I'm going to ask you to graph y equals the square root of x minus 3 plus 2, I'm going to ask you to plot that. What are you going to pick for values of x? I want to make perfect squares, right? I want to create perfect squares underneath that radical. What's that? Yeah. Yeah, exactly. You hear what Caleb said? Remember your perfect square list? 0, oh, not 0. 1, yeah, 0. 0, 1, 4, and 9. Those are your perfect square lists. What do I have to add to it? Add 3 to it. Why do I have to add 3 to it? So all you're doing for your picks then, you're going to add 3 to them. So the numbers that I'm going to pick are going to be 3, 4, 7, and 12. Because those numbers are going to work quickly, and you can do that in your head. Does that make sense? And then to that, you just shift it up to them. So it's very, very, very easy to work with. I know we talked about it, just want to remind you of that. Otherwise, the other thing that I was seeing when I was going through the homework the other day was your equation, or the slope of the secant line, the change in delta f of x, those. Let me show you. This isn't it. You guys were doing there's a 1.5, sorry.
But just replace the test again, or what was after the quiz, or including the quiz?
It's including the quiz and what we did with the graphing and this delta f of x stuff. That's why I want to go back
So
over it.
will we need the note of what you used
Yeah, do you get a new card?
Oh yeah, you still get note card. I have note cards. I think you guys want. Absolutely.
Are we able to use our same one that we used last time?
If you want. Oh, I have them. And you know where they are? They're at my house on my official table. But it'd be good for you to make a new one. They'd force you to study. No.
Or you could,
Excuse me, why are they on your quizzes?
Yeah, I will. I have them right there. I'm just looking for the change in X1 for you guys. The test will be calculator, non-calculator, so you guys know. Here we go. Average rate of change function. This is that average rate of change. When they're asking you to find the, yes sir? Tomorrow. Told you that last week. Kazam. Average rate of change. What this meant was it was asking you to find the change in f of x over the change in x. Remember, the change in f of x is you have to substitute in the values of x to figure out the f of x. The only thing that's different from what you guys have done in the past with just slopes is that now you have to figure out your y coordinates. They're going to tell you your x coordinates. You have to substitute in to solve for your own y coordinates. That's all f of x stands for. F of x in this case, remember, same thing as y equals. Okay? So if I'm looking at this, I want to find the average rate of change of this function between those 2 points, 1 and 5. Well, that means I'm going to take 5, substitute into here. So we have 5 squared minus 2 times 5 plus 8. Well, what's 5 squared? It's 25. Very good. Oh, that's a sarcastic one. And it's 25 minus 10? What's 15 plus 8? 23. So the first one is 23. 1 squared minus 2 times 1 plus 8. What's 1 squared?
1.
What's 1 minus 2?
Negative
What's negative 1 plus 8?
7.
7. So our two f of x's that we're working with are 23 minus 7 over 5 minus 1. Yeah, that's right. So in this case here, the slope of the secant line, the average rate of change, is 4. That's it. Later on, you guys you might have to actually write the equation of that line. Well, you have a slope, don't you?
Yep.
Do you have ordered pairs?
Yep.
Yeah, because you knew that at 1, it was 7. You also knew that at 5, it was 23. If you know a slope and a point, can't you use point slope form and write the equation? It's the same thing, guys. You've done that problem. You did that problem back in Algebra 1. Just so happens that when you get to pre-calc or calculus, it just gets, they use fancier terminology to get you there. That's awesome. Okay? Average rate of change, remember, it's f of x over x. But you have to figure out what f of x is. Okay? Difference quotient, that was the other one that will be on there again. We did that. Yeah, and then just direct substitution again. Difference quotient, I'm going to show you.
Is the formula going to be on the quiz?
Yes, it is there. Because it tells you what to do.
Because I wrote it on my note card last time.
You should bring those note cards.
Oh, yeah.
Remember, what you're doing here, when you're trying to do that difference quotient, it's substitution again, and you're trying to get rid of h. Okay? Trying to get rid of h. So in this example, it's f of x equals x squared minus 4x plus 7. Find f of quantity x plus h minus f of x all over h. Your question was, will that formula be on there? Yes. It has to. And it has to because I might ask you what is f of x plus 5, you know, that we're using 5s and stuff. You can do all of that. Okay? So as you go through this, it's a direct substitution problem. You get x plus h, quantity squared for the first part, minus 4 times x plus h plus 7. That is f of quantity x plus h. I just substitute in. The second part then is to subtract the original equation. But what do you have to remember to do? Distribute your negatives. Okay? When you go through this, what is junk squared? Times. Trying to be done as much as possible. Okay. It's junk times junk. Hopefully by now you can FOIL that out without having to write it out, right? First term squared, last term squared, put the two together and double it.
So x squared. And then subtract x squared, add 4x, subtract 7. And what am I dividing this whole thing by? H. Now it's just combining like terms. Okay? It's a matter of just combining out all your like terms. We do that, we get x squareds go away, 7s go away, 4x goes away, and I'm left with 2xh minus 4h all over h.
H squared.
Oh, thank you. So, what can we factor out? We factor out an h. We get 2x minus 4 plus an h all over an h. And those drop. And that would be your thing. Okay. It's not terrible, but I think a lot of you guys just freaked out because you haven't seen that kind of seen it written out like that before. Okay. You haven't seen that stuff written out. Don't forget how to find zeros. Factor things, set them equal to 0. What else is there? It should be a lot easier than what it was first time around. I think you guys are a little bit more ready for things to actually work this time. Let me get you guys a couple of note cards if you need them. So you guys probably have one for you. If you need them, come grab them. I'm leaving them on the desk here.
Top right corner is
You
mine.
can have one. Yes.
Touch it, you're done.
What? Who was it? Yeah. Yeah, that was when you substituted x, or substituted negative x for f of x. It was in one. I believe.
Is that going to be on there again?
It might be.
Hey.
Hey!
We're gonna end up having to get you. It's like the difference quotient all the things that you overlap. Counted the one or the well, like, I mean, if you multiply that and you just look at the x squared,
Just take it together, it's like
Yeah.
h squared times the
Yeah.
other x is